Basically, my idea topic is about smart air and noise pollution monitoring system. I suggest to design a system which is smart to calculate the amount of air and noise pollution in our surroundings. By using this system, we can monitor the amount of air pollution and noise pollution uh, nearby us in real time. So that's the idea statement. Due to the urbanization, we are producing more and more pollution day by day, whether it is noise pollution, air pollution, water pollution, or there are many forms of pollution. But in my implementation, I suggest to measure the air and noise pollution because these two pollutions are very harmful from the patient's point of view also, because there are many diseases which are caused due to air pollution like asthma and many kinds of lung cancers, etc. So, and the noise pollution can cause hypertensions and all, and which are very common nowadays. Also heart attacks and all are caused by air pollution also. So these things are very common. So why don't we design such a system with which we can monitor the amount of pollution so we can act accordingly. So that's the basic idea statement. The purpose is real-time monitoring of air and noise pollution. So the existing system what we have in today's world uses all these technologies, like these are the monitoring systems which we use in the existing systems which are there. We use sensors, we use Zigbee, RFID tags, mobile phones, and wireless sensor networks for measuring the different amount of values, or uh, like temperature, like humidity, moisture, or other things. We measure by these things. Then we uh, the sensors, Zigbee, RFID tags, these all provide the details to a database through these mediums like ADC, MCU, and WSN provides by WSN gateway. All the different protocols are there for different systems. So from the server has a database, and database attached with the web service, which can be contacted by LAN and over the internet. So by using web browsers or phones or any other devices, we can make use of the all the details with the sensors and all technologies are measuring and all. This is the existing system. So these are all the explanations of what is RFID. RFID is a means of storing and retrieving data through electromagnetic transmission, and it's basically a no contact device. Like you don't have to make the RFID reader in contact with the RFID card. It it does all the things by electromagnetic transmission. So this is RFID. Mobile phones, the explanation of mobile phones, smartphones, which have all the sensors. In today's world, you don't need extra sensors. Your mobile phone has all the sensors. So wireless sensor networks, this is explanation of wireless sensor networks. I'll be coming on the wireless sensor networks later also. So what is a proposed system? So the proposed system is an embedded device which will be monitoring the noise and carbon monoxide levels in the atmosphere to make the environment intelligent or interactive with the objects through wireless communication. So the proposed model is more adaptive and distributive in nature than the existing system. In the proposed system, I don't use the technologies like Bluetooth and Zigbee. Instead, I use the wireless sensor network technologies, because wireless sensor networks, you can sense the information, you can send the values directly over the internet through wireless sensor networks. So that's what I'm suggesting. Like I measure the values from the sensors, then I upload them to the, like I send the values to the microcontroller system, which is a decision making system in my model. Then by this microcontroller, the values are compared in the threshold by the threshold, and then these values are uploaded on over the cloud. So cloud is the most important part in IoT. We cannot like separate cloud and IoT from each other, because by the cloud we get a real monitoring or real time data of our system, and those values can then be used for further analysis and getting some results for data mining, for analysis, these things. So the conceptual idea of the model is like various gases and noise sensors are attached to the system, which will detect carbon monoxide, sulfur dioxide, etc., and the amplitude of noise also. These are the different sensors for that. So these values will be fed to a decision making system. In my model, I use Android 80 mega 328 to analyze and control the system, because the this board is capable to hold a large amount of data and simultaneously contact with the cloud wirelessly. So I'll be using some Wi-Fi module or something to connect it with the Wi-Fi, and then feed all the values to the cloud. So Arduino in locally what Arduino does is it compares the values, the respective threshold value. Those threshold values can be decided by a long time analysis of the all the values, like uh, so these threshold values are not like fixed, but this can be decided by some kind of analysis of a data sheets of various sensors, and uh, made available by the government also. So these threshold values are then fed, and then the current values are compared with the threshold values, and accordingly they decide that what is the pollution level, whether it is a great amount of pollution or it is a normal. So based on this you can decide it. So main thing is these values are also sent to the ThinkSpeak cloud. In my implementation, I use the ThinkSpeak cloud, which can be used by the various government organizations and other organizations to analyze the pollution levels in the city and act accordingly on them. So on the ThinkSpeak cloud, the advantages, why do I choose this cloud only? So these all the things I'll be coming in the later part. So the concepts involved in the model is the first, the concept of cloud. What is a cloud? A cloud refers to a distinct IT environment that is designed for the purpose of remotely provisioning scalable and measured IT. This is a book's definition. Basically, the cloud is what? Cloud is a thing. Cloud is a is thing which can replace your computer, your CPU, your RAM, your memory. It can save you from all these things. Cloud provides three kinds of services. Three kinds of services which the cloud provides. First is IaaS, infrastructure as a service, platform as a service, and software as a service. Infrastructure as a service means infrastructure is basically the hardware resources which you need for your system, like RAM, CPU, memory. These things are infrastructure. So these services are provided by the cloud. Your data is analyzed, your application is run on the infrastructure provided by the cloud, not on your local system. This is the first very basic advantage and the service provided by the cloud. Second one is platform as a service. It provides you the various platform, like you want to run your software on Windows, on Linux, or many. There are many platforms you can have. But on a local machine, you can't have all the platforms. You have a limited number of what you can do on a local machine. But the cloud, you don't have any limits. You can choose any cloud platform or anything, so you can run your application on that. The software as a service is kind of thing, like you can take for example, Gmail is a software which is on cloud, but you don't need to install these software. You don't need to install it locally or something. It is just deployed on the cloud, and you can directly use it from the cloud. This is software as a service. So the proposed model makes use of all the aforementioned cloud services to work efficiently, effectively, and reliably. So this is the use of cloud in my model. The concept of Internet of Things, like Internet of Things is a networked interconnection of everyday objects which can be living, half living, or non-living things. So this is a concept of Internet of Things, which is like in today's world it's an inseparable part of any application. Like any application, any gadget you take, it consists of IoT somewhere. IoT can make your device more effective. You can have a larger audience, you can have more advantages than the conventional devices, and all that at a lower cost. So that's IoT. So that's a basic architecture of IoT platform. You have a client. First you have a data layer. You have various sensors. You send these sensors data through various messaging protocols, which can be HTTP, MQTT, or there are many AMQP. There are many protocols with which you can send these sensor data to the sensor web service, and these are the various sensor web service, the wireless sensor networks, SOS, SPS, and by these web service, the this is the application layer where all the data is analyzed and uh, all the according to your application. Then this is a client layer, what we deliver to the client by making use of this sensor information and analyzing it here, then we deliver it to cloud. This is the basic IoT platform architecture. So concept of wireless sensor networks, as I was saying previously. So I'm coming here. Now what are wireless sensor networks? Wireless sensor network is a consists of specially distributed autonomous devices using sensors to monitor physical and environment conditions. So a wireless sensor network is just not just a sensor. Basically, it consists of many things. Like this is the architecture. This is the basic architecture of a wireless sensor network. It consists of radio. It can consist of battery, microcontroller, analog circuit, sensor interface, and network. Some network protocol, some networking device which can communicate over the internet. So this is a wireless sensor network. Not it's not just a sensor, but it's a sensor with a network. So these are the basic protocols which you can use in wireless sensor networks provided by IEEE standard 802.15.4 Wi-Fi, 802.11 Wi-Fi, or these are the various frequencies you can use. Other things are also there, but these are the standard IEEE protocols for wireless sensor networks. Then WS architecture, this is a basic architecture. The photo is not so visible. Okay, the standard IT technologies we have your database connectivity, standard Ethernet connectivity. These are the Wi-Fi IEEE standards, and these are the various sensors which we have. This is the architecture of wireless sensor network. Then the network topology is wireless sensor networks use basically three network topologies are there: star, cluster, and mesh. In the star topology, what we have is we take data. The data is fed into these leaf nodes, then it goes upward and upward to the and finally reach to the gateway. This is a star topology. Same thing happens in the cluster tree topology, but basically it's a combination of star topology at multi-level. It's a cluster tree. The data is fed here and it goes to the more complex levels accordingly. And these black denotes the gateways and these blue are the nodes for sensors, what you say. And the mesh is some advanced kind of topology. It does not mean like data is fed through the leaf and all. The data transmits and the travels to the path which is the shortest path. It will decide the shortest path itself. So it's a very advanced topology for wireless sensor networks. So these are all the advantages of the technologies make wireless sensor networks more suitable for my application. So the components I described, what are the wireless sensor network consists of. So basically, we will coming to the hardware architecture of the project. The My idea uses this hardware architecture what I designed for the system. So this hardware architecture is something like it has five layers. Five layers are there. So the layer one provide details of functionalities of different reasons to be monitored, like air and noise pollution, by from which I measure these things. Transportation intelligence station, indoor and outdoor monitoring, industrial management, healthcare. These are all the like some example organizations from which I can measure the pollution levels. I can measure it from road. I will be traveling on road. So all the sensor devices, these get the information about the pollution levels to the sensor. These sensor will get the air, will get the noise input from various places. Then these sensor devices have some threshold. We have some threshold to be compared the value with. We have some time duration. We'll have the day and night context, whether it is day or night. It will also affect noise. It will also be dependent on day and night condition. We have an alarm system with us which will trigger the alarm if the pollution level is very high than our threshold. Then this sensor data acquisition and or context recognition, it's there. We acquire all the data from our sensors. This is the ambient intelligence system what I'm talking about. It is a that microcontroller system, or that's a system which will be comparing all the values. It will be a decision making system of the project, and then these values are served over the internet, over the cloud through the internet. Then all these values are uploaded over the cloud, and by the cloud the government can make use of these values, or any other organization can monitor these values, and they can analyze these values for different purposes. Basically, this is the thing. These values represent data flow, these control. Because control happens, cloud will trigger all the cloud. We upload all the values on the cloud. So by computing all these things on the cloud also, we can control this whole architecture. It can be controlled two ways. One by this intelligent system, one by the cloud also. So because the description of all the layers. And coming to the software architecture, the model is basically based on wireless sensor networks. So the pollution values detected by various gas, smoke, and sound sensors, and these values are communicated to the microcontroller. So the microcontroller is Arduino 8 Mega, and the microcontroller will see the value and it will compare the threshold value. That's a simple thing. And it will one more thing is, like, what I'm specifying with my project. My idea is to help the users to decide which road to travel on. Like, you have two ways or three ways to go, so you will have the product video. It will analyze the pollution values, and accordingly it will tell you the best way to travel on. Like, Google Maps tells us the shortest path, the shortest time, the short means lesser amount of traffic will be on which road. So basically this system does the same thing. It can determine the it will suggest you the road you should take based on the traffic, based on the pollution levels. So you should take the less pollution level road. So this is a very very big advantage of the system. So the important part is also you send the all the values over the cloud for analytics purpose. This cloud uses the cloud used. The idea is the ThinkSpeak. And now I'll be coming to more specifically on the ThinkSpeak cloud. So why did I choose this cloud, and what are the various advantages and services provided by this cloud? The ThinkSpeak is basically a cloud uh, owned by MATLAB. MATLAB is a software company of MathWorks. So MathWorks provides MATLAB. It also provides this ThinkSpeak cloud. So the ThinkSpeak cloud has the ability to easily configure devices to send data using various IoT protocols. It's a cloud majorly specifically designed for the IoT only. ThinkSpeak cloud. I know that thing you can do except IoT. All other clouds have a add-on service for IoT, like Bluemix Cloud. IBM provides Bluemix, Amazon provides AWS, Google provides its own cloud. So these all clouds have an IoT section for them, but ThinkSpeak is basically specifically for IoT. So let me show you on the website of ThinkSpeak. This is the website of ThinkSpeak. So this is I have logged in already. So what I can do is, with ThinkSpeak Cloud, I can what I can do is I can first I will send the sensor data privately to the cloud. With privacy is also maintained by using various security protocols. So I'll send all the sensor data privately on the cloud. I will analyze and visualize all data with MATLAB code. Like, that's a very uh, feasible thing on the cloud, that you can write all this analytics code in MATLAB. It is very useful. It is very easy because MATLAB is specifically for mathematical analysis. So you can plot various graphs and all, and very easily with the use of MATLAB. So you can upload all your MATLAB code. You can write on all the MATLAB code on the cloud and analyze it. Then you can trigger a reaction. What reaction? Like, you can trigger a reaction for a tweet, like give me a tweet, or post me an SMS when when the values are more than threshold. Thanks to cloud. This is basically a channel what I have created on the cloud for my IoT project or smart traffic control. This is an example I'm giving. So this is the channel what I created. This is our channel ID, and all these are various views, public view. So these are the API keys which the ThinkSpeak will provide me to write my data on the cloud. This is the write key. This is the read key, through which I will make use to analyze my data, or write my data, or read my data. Yeah, so private view, let me come to private view. So what I had in my IoT product is I had four roles. I had to analyze them. road density, traffic density on the four roads. It was a smart traffic controlling system using image processing. And so I was calculating all the four roads, all the traffic density on the four roads, and accordingly I was turning the lights green and red. So these were the various visualization graphs which I got. So these points are the amount of road density. Like the road 10, the density was 10 at this times 10. May 3, 2017, this time. This is some other data, some other data. So this is road 1 density graph, road 2 density graph, road 3, road 4 density graph. So these are the visualizations you can get from the ThinkSpeak cloud. This is a location. This was the location of my IoT device. It consists of all the proper location over in VIT. So this is a location value, and these are the latitude longitude graphs. So I was at a single. I was at a single place, so that this graph is constant. There is a latitude graph. What are the latitude coordinates of my sensor, of my device nodes. So for all these points, there are a corresponding latitude point as well, which is constant. I was at a constant location. Same for longitude, I was at a constant location. So and these are the analysis which I can do. So these are the graphs I plotted for my values, and this is the analysis what I did with those values. This shows me the weekly traffic analysis, monthly traffic analysis. These are the graphs of. Let me show you some visualization. How can we write the visualizations within Speaker. I completed all my visualization which I have done. Like this is weekly traffic analysis. So let me run this. So let me edit this. So this is the code which I have written in the MATLAB for my weekly traffic analysis. By writing the same kind of code, I can analyze my data very efficiently on the ThinkSpeak cloud. My data for pollution also I can analyze it for the same thing. This is the end date, this is the start date. So this is the weekly analysis. So I have 3 May to 27 April to 3 May. So this is yeah, 27 April to 3 May, that's a week. So this is the all traffic data. This is basically the code to analyze, and this is plotting all the data, all the four things, all the four road densities with respect to timestamp and the traffic data. All four times I plotted on the same graph. So this is basically a very powerful tool to analyze our data within Speak Cloud. Also, these are the method and visualizations I can create. All other things are also there because once you can explore more things. Because so let me continue my topic with you. So, yeah. So the basic flowchart of my system is start, sends the pollution information, convert analog data to digital because the sensor will send some analog data. You have to compute this data into digital and compare these levels with standard reference value which you have calculated already. If pollution level is high or critical, then wait. And if the pollution level is not high, so I'll wait for 15 minutes. So I can set any time. So it will be going back to the start and then repeating all these things again. But if my data is critically higher than the threshold, then the data packet should be sent like this, like transmission ID, start with data, stop with, and I'll be sending this all information. So send data through the transmitter and wait for some time and then start the process all over again. This data is sent over the cloud from here. This is a basic flowchart working in the system. Now coming to the pros and cons of the system. There are many pros which you can think of the system. The model presented gives a real-time monitoring of air and sound pollution. It can trigger an alarm when pollution levels cross threshold. It will be sending the pollution data over the cloud. Statistical analysis can be done over these values over the cloud. So patients of several diseases like asthma, lung cancer, hypertension, as I was explaining earlier, also they can make use of the system to decide which place to live in. So it is more polluted place, so you should not live at this place. Then, yes, uh, if you're thinking of buying some home or something, you can analyze the pollution levels there. Or you are traveling, so you can analyze the pollution levels, and accordingly you can decide the road you should take which have less pollution. So they can wear masks accordingly based on pollution levels. On a particular road there is more pollution, so you can wear mask at that time, because you cannot, I think you cannot analyze yourself whether the pollution is higher or low, you should wear the mask or not. But the system can tell you, this smart system can tell you to do this. So the system can be used to decide which way to travel based on the pollution levels, as I explained. And these are the various government organizations, these can they can make use of the system to analyze the data and act accordingly. So they can analyze in whatever requirement they want it, they analyze the data. So there are some consequences also which I have not implemented. So these are the consequences. The first consequence is that the number of gases detected by system will be limited, because of the gas sensors. Because gas sensors, a gas sensor particularly, it has three or four gases which it can detect only. It cannot detect all the gases, but there are infinite number of gases which are also harmful to us. What I'm uh, implementing is with major gases like CO, SO2, which are the major pollutants. But there can be some minor pollutants also, but I cannot like attach all the gas sensors. Like, I can attach MQ2, MQ5, and basic some very popular gas sensor, but there can be many gases left which cannot be detected. So that's a consequence. Other consequences is uh, like same thing. There are many harmful compounds other than gases also can be there which cannot be detected by these sensors. So the last consequence can be like the proposed system only monitors the traffic levels, or sorry, pollution level. Or it does not give me any suggestion to reduce the pollution level, anything like that. So this is also a major consequence, because I only monitor the data. I cannot suggest something to reduce the pollution level by my system. So the conclusion, what I conclude is that the proposed model is a reliable and robust system for pollution monitoring if it is implemented in a proper way. So it measures the amount of noise and air pollution which can be used for various purposes, as I explained. So the future scope is, in future I think that there can be many future enhancements which can be implemented. So one such enhancement I give is to overcome the consequence number three, as I explained this. It does not give me the suggestions for to reduce the pollution level. So that can be done by using some various machine learning and artificial intelligence algorithms like neural networks. And you can train your artificial neural networks to by analyzing the data for a very long time to suggest some ways to minimize the pollution levels. Also, government issues some data sheets for the various sensors it have on various satellites. There are many things. They are like weather forecasting, and also they have all the data of the data sheet they issue. So by analyzing that data sheet, by analyzing all the amount of data, so we can train our neural networks or our system to suggest some ways to reduce the traffic, to reduce the pollution actually. So also, if one more feature enhancement I suggest is that system can be modified so as to predict the amount of global warming or other climatic conditions in the future by analyzing the pollution of today, by using some uh, logistic regression method or something, some regression techniques like exponential for forecasting or some techniques like these. So I can predict the amount of global warming or the temperature which is gonna be like the next year into 2018. What will be the highest temperature in the year? What will be the amount of global warming in that year? So I can determine all these things by analyzing these pollution values for a very long time. So I leave these problems for further future research, and uh, I just pause myself on here. So it was Weber Pandelwan explaining my model for the digital assignment one of IoT. So thank you. Thanks for watching.